there's a grain of sand between us. If you pick it up, you won't feel anything special. It's just so tiny and light and dull. But let me show you something. This grain of sand is part of a meteorite that fell to Earth from Mars. And if we cut it open, we'll find inside a secret record, one of the oldest on Earth, written in the language of the entire universe. This is evidence that the laws of physics work exactly the same way on other planets. And by studying this ancient Martian writing, we've unlocked some of the most fundamental laws of nature. But there's even more to this story. See, this sample of rock is not just a record of the laws of nature. It's a record of something much older. A beginning when Mars was molten and Earth wasn't around at all. This is the oldest piece of evidence we have for the fact that our solar system didn't just form fully formed like a plate of cosmic oatmeal. It evolved. And now we're uncovering another kind of evolution happening to the universe itself. We think of the universe as constant, unchanging, a backdrop to human drama. But really, everything we know is evolving, expanding, accelerating away from each other. Everything we can see, every galaxy, every star, planet, nebula, and comet, they're all flying away from each other through the void. It's not hard to prove. Just look at distant galaxies. They're all redshifted. Light waves stretch into the infrared as the universe expands. But that's just what we can see. What about all the stuff we can't? There is nearly 10 times as much matter in the universe that we co-see as all the stuff we can. We call this dark matter, and we can only observe its effects indirectly through gravitational lensing and galaxy rotations. Dark matter is like a ghost, an invisible presence that influences everything around it, but never reveals itself. And it's not the only ghost in the cosmic closet. There's also dark energy. To understand what that is, let's talk about space. How big is it? Well, that depends on how you measure it. You could take a ruler and measure across a single galaxy, or you could measure across a cluster of galaxies. You could even measure the distance to the edge of the observable universe. But no matter how far you measure, you get the same result. Space is flat? Oh, due to weak no. Because on the largest scales, space looks like a sheet of paper. It's completely flat. Now, if that were true, the universe would be doomed to an inevitable heat death, where everything drifts apart forever. But the universe isn't just expanding, it's accelerating. It's speeding up, and we don't know why. That's dark energy. It's like an unseen force pushing against gravity, stretching the fabric of spacetime. So the two biggest components of the universe, dark matter and dark energy, are both invisible, and we don't know either of them exist except through their effects. Together, these make up 85% of the universe, leaving the stuff we're made of in the cosmic dust. So the next time you look up at the night sky, remember, you are not just looking at points of light. You are looking at an infinite cosmic ocean of giants and ghosts, of voids more massive than our comprehension, and forces that shape reality itself, all operating on a timescale that makes human history feel like a fleeting whisper. You and I, we're just starting to explore the nature of the universe. We're finding our way in the darkness. But there are others who have been exploring the darkness for decades. I'm talking about scientists at the South Pole. This is Amundsen Scott, an Antarctic research station. It's a place built for one purpose: to peer deep into the heart of the universe. The station is staffed by about 150 people during the winter months. They live, work, and conduct experiments below the surface, 2 miles beneath a kilometer of ice. Why here? Well, the South Pole is in the best place on Earth to look at the cosmos. It's perfectly situated to see the northern skies unobstructed. And that means this is the best place on Earth to watch the cosmic microwave background, the afterglow of the Big Bang. That's what makes this place special. This is my favorite place in the world. And right now, it's your turn to experience it for yourself. You're standing at the Amundsen Scott station. All around you are your fellow scientists. Some are checking equipment. Others are sitting at their computers, watching data streams roll by. But everyone is waiting. Waiting for what? For a once-in-a-lifetime opportunity. In front of you is the portal to the Ice Cube Neutrino Observatory. This hole goes down 86 stories, deeper than the deepest mine on Earth. At the bottom, 5,000 digital cameras surround 160 string sensors. These are the eyes and ears of Ice Cube. They listen for the faint signals of neutrinos raining down on Earth from distant supernova. Neutrinos are ghostly particles with no electric charge and almost no mass. They're the most abundant particle in the universe. Every second, 100 billion neutrinos pass through your body. But until Ice Cube, we knew almost nothing about them because they interact so rarely. Neutrinos carry information from the most extreme environments in the universe, places we can never observe directly. When they strike Earth, they reveal what's happening in distant galaxies, what happens in a supernova explosion, the death of a star. That's why Ice Cube is so important. It's listening for clues about the most violent events in the universe. It's looking for the whispers of the dead stars to learn what happened in their lives. We're going to go deeper, much deeper, to the darkest, coldest place on Earth, to see how humanity pushes the boundaries of knowledge in the face of unimaginable odds. But first, we need to talk about the most important invention in the history of astronomy, the telescope. Since Galileo first pointed one at the sky nearly 400 years ago, telescopes have gotten bigger and better, revealing more detail and clarity than any human could ever hope to achieve. Today, the largest optical wavelength telescope currently in operation is the aptly named Big Eye, located high in the mountains of northern Chile. Now, despite its name, the Big Eye isn't actually that big. In fact, it's smaller than the Keck Observatory in California, but it uses a technique called multi-conjugate adaptive optics, which allows it to correct for atmospheric distortion, giving it a near-perfect view of the universe. It can see things 20 times fainter than Hubble and resolve objects 10 times smaller. It's so good, in fact, that you can use it to see things that are thousands of light years away, and as small as a coin. And it's all thanks to this thing, a device called a deformable secondary mirror, which can change shape in real time, compensating for distortions caused by the atmosphere. I can't show you what it sees, because it's currently under construction, but I can show you what it will see. Details on things like the birth of new stars and planets, never before seen in such exquisite detail. The first exoplanets discovered orbiting a star similar to our Sun, and the atmospheres of planets similar to Earth. These are just some of the mysteries the Big Eye will help solve. But it's not just about what we can see, it's also about what we can hear. Sound travels through space as a vibration, so if we had ears in space, we could hear all sorts of interesting things. We could hear supernovas exploding hundreds of light years away, creating sounds similar to a symphony orchestra. We could hear neutron stars orbiting each other, creating eerie, beautiful sounds like a cosmic violin. And we could hear black holes tearing apart matter, creating a sound like fingernails on a chalkboard. No, seriously, that's what it sounds like. It's creepy. And we could hear all these things because the air molecules in our lower atmosphere would vibrate when the sound waves hit them. But wouldn't it be cool if we could hear these sounds here on Earth? It turns out we already do. Listen closely. Do you hear that? That's the sound of the universe. Can you believe that? The universe has a sound. It's a chorus of cosmic wonders, a symphony of stars, a requiem for black holes. It's the music of the spheres. This is the power of the telescope. It shows us things we've never seen before, and it lets us hear things we've never heard before. It gives us access to information that was never available before. It's a window onto the past, onto worlds that existed before ours, and onto realms that are hidden from our view. The question is, what will we do with this power? Will we use it to expand our knowledge, to deepen our understanding of the universe? Or will we use it for more selfish reasons? To spy on our neighbors? To hunt for resources? Well, that's up to us. We are the ones who decide how we use the power of the telescope. We are the ones who determine the future of humanity. So let us use this power wisely, with humility and respect for the universe and everything in it. Let us use it to understand, to appreciate, and to explore. For in doing so, we will be doing more than just advancing our own knowledge. We will be expanding the horizons of all humankind. The secrets of the universe are out there, waiting to be discovered. It's up to us to go out there and find them. Are you ready to join the adventure? That's 1 minute. See you tomorrow.